to like delve into SPSS or the community health survey. Now, why was this important? Why is this statistic particularly important if I'm going to apply stuff from that community health survey again? What kind of 95% of the data, 98% of the data in that community health services survey is what kind of data? Categorical, right? And this is a tool, this is the first tool really that we have for analyzing categorical data. Odds ratio, relative risk, chi-square, those are all tools that we can use to set up tables from EpiQuery and from the community health survey data and so on and so forth. Okay, so now I'm going to go to community health survey. I'm going to go online to the community health survey, and there is a place there that you can get to. If you go into data and statistics, oh no, I didn't want to do that. If you go into surveys, it says community health survey. See it there? And if you go into the next thing over here, it says public use data. I'm going to click on that. Okay, so over here I see that I have a description of the data set, and then I have community health survey public data sets. Oh, look, 2013, 2012, 2011. For each year that they've done this, right? You don't have 2014, they haven't compiled the data yet. For each year that they've done this, I have a copy of the questionnaire. I have the code book. We'll talk about the code book in a second. I have the actual data itself. The actual data itself happens to be in a format that they use for the Department of Health from a program called SAS. Okay, we have a formatting program. Okay, formatting program and format statement program. SAS, especially older versions of it, store the formatting, the coding of the data separate from the data itself. You know, when you look at the values and stuff like that. So these formatting programs tell SAS what the values are. If we're using SPSS, we're not gonna. That may come in handy for us, but unfortunately, when we import it, you'll see what we get, and it's like you're gonna need to go back to that to fill in a little bit of information. But I mean, we have a lot of interesting stuff here. For instance, the questionnaire. I'm gonna click on that. Here's the questionnaire. This actually, see, it's broken up into sections, and this has the actual questions and what the different choices might be, and some other information about how they chose it, and how the survey was set up. How are you calling? Are you calling landline? Are you calling this? But they have the actual questions in here too. And then, for instance, if you question one is this response, you go to question, go here and do that, and so on and so forth. It's an instruction for the person that's actually giving it, not in addition to the. I got lucky here. Question 7.15 about how tall are you without shoes, right? What kind of variable is that? Numerical, right? It's height, right? I'm presuming they're going to talk about inches here since we're in the United States. So, actually, they might convert it. I don't know. We'll have to take a look at the data. They're asking about height. So that's unusual because I happen to stumble across a numerical variable. Most of it is categorical variable. They actually convert the data into categories. They might have even done it there, short, tall, whatever. But we'll see when we get to that data. Okay, but there is some numerical data in the survey also. Okay, so now, oops, I didn't mean to close that. So I can't get back to it. Okay. Here we go. Okay. Okay, so here's the data set for SAS. Now, unfortunately, I can't run SPSS on here, so I'm going to switch over to the other machine. And I've downloaded, in order to download this, all I have to do, I'm going to hit Control on PC or Mac, hit Control or right click, and I'm going to right click on Dataset SAS, and I'm going to say download link file as. You can't see it there, but there it is. You can see it. It's .sas7bdat. That's probably a version number. SAS and a version number that describes the file, right? And I can save that. I save it to my desktop, for instance, right? It downloads it. It's a pretty big file, but it downloads it to my desktop. So it's a 15.9 megabyte file saved on my desktop right now. I can also save the questionnaire and the code book. I'm just going to download the code book. Okay, and we'll take a quick look at the code book. Take a look at the code book now. Oh, look at this. Now, the code book tells us that the variable that's named diabetes 13 is the response to the question, have you ever been told by a doctor or nurse or other health professional that you have diabetes? And what's the response to that? The response is either if it's a one, they answered yes. If it's a two, they answered no. The other things here just refer to missing data, really. So what kind of variable is that? Categorical variable, right? It's a yes or no answer, right? And if we compared that with gender, somewhere in here there's gender. Gender is male and female, right? I don't know. They might have nowadays. They might have transgender or some other categories. I suspect that like just to keep it consistent with the others, they might just have them report what they consider their gender or something like that. Keep it male and female. So it's consistent with, so they can compare it to the other databases. I'm guessing, right? But we can look it up, right? But in here we have what these numbers represent. Okay, so I'm going to switch over to the other machine, and I'm going to actually take this data from SAS and I'm going to import it into SPSS. Let's change machines here. Okay, let me mute everybody here. Oh, Levi's mic is on. Good.
Sorry about that.
No, that's okay. As long as you aren't making noise, it'll be okay. Okay, so at any rate, let me see here. I'm going to make him the presenter. Make this the presenter. Make presenter. Okay. Okay, good. Okay, good. Now, the presenter is up there. Oops. Okay, I'm going to have to come around to this side here. Actually, see what's going on here. Okay, and I think that shows the screen. Yes, it does. Okay, so now I'm going to go down here. I'm going to open SPSS. Well, programs is probably going to be under IBM. Yeah, IBM SPSS statistics. And I'm going to open, I guess, just that one. Probably be the closest thing to the. Move this over. I can't move it over. There it goes. Okay, did it open up? World's slowest program to open.
Yeah.
We'll give it a moment. There it goes. Oh, hope it's much quicker on this thing than most of the other machines here. Okay, good. So it opens a blank data set, data file, right? So I have to leave that open because you can't close that. It's always have to have one open. So I'm just going to click File, Open, Data. Now I have already imported to the desktop that SAS file. Okay, and do you see it there? I see a demo. That's not it. I don't see it there because the only thing it's showing me right now is files of the type .sav, its own files. So I'm going to change that to, I'm going to scroll down here. You can see there's a number of formats you can read. And here's SAS files, including that SAS7B DAT that we're interested in. And in fact, now here that file appears. Okay, that's the file we just downloaded from EpiQuery, and that's the actual raw data. Okay, whoops. So I'm going to double click that or say open. Opens up my output page to let you know what it did to open it and so on and so forth. And here is all of our data. Okay, in other words, we're in the variable view, right? So these are all the variables listed. Each row represents a different variable. Remember we were talking about weight? Here's BMI. It's a numeric variable. Now it's identifying a lot of them as numeric variables. But if you go, because it sees numbers in there, but if you go over here to the type of measure that it is, it's correctly identifying most of them as nominal. It sees that the values are 1, 2, 3, for instance. So it says, that's probably not a numerical variable. It's probably a number representing a nominal variable, a categorical variable. Some of them, it says, look like scale. So, for instance, some of them are right, some of them are wrong. Here, birth region, right? There's probably so many birth regions that it sees many numbers, right? Maybe 1 through 13, and it's thinking, maybe that's scalar. I better make that scalar. One of the things that you're going to have to do as you go through this data, and if we spread this out, see this label over here? I spread this out. You got the questions, right? Or a summary of what the question was. Oh, I didn't want to do that. Right. I want to click just that column so I can spread out just that column. You can literally go through all of these See how many variables there are. Oh, there we go. There are 209 variables. You can go through these variables and look to see if there's stuff about this that you think you want to examine. For instance, you have information about the number of sex partners that they reported. You have information about birth control. You have information about diseases, diagnoses for diseases, about mood, about there's all sorts of stuff in here. Number of sugary drinks that someone drinks, number of fruit, the amount of fruit someone eats, and so on and so forth. You have all sorts of variables in here. So now you guys can go through this and see, well, gee, yeah, I really think there might be something interesting to examine these group of variables. Okay, up until now, we had what we needed to deal with numerical variables and categorical variable, numerical variables, because we had a t-test analysis of variance. Now we have what we need to deal with categorical and categorical variables. Right. So you can go through this and you can pick out the ones you want. Now, I'm going to go back to the data view here now. Okay, and here's the data view. Right, you got this is the variable name, right? The label is more, see the label is really more like number of adults in the household. The label there is num adults, right? Obviously, this is much more descriptive, the label, than the variable name is. So you can use either one of them. I go back here. These are all variable names. If you hover over them, it'll tell you, it'll show you the label, that longer description. And how many rows how many columns are going to be here? It'll be 209, one for each row, right? This is the actual data itself. Right? You might be able to notice which ones of these are numerical. Nope. What do we got here? Oops. Oops. Did I do something here? Did I lose it? There we go. It's back again. Okay, this is, I'll hover. This is ounces of other sweetened drinks that you drink a day. So this is the number of ounces, 777 ounces. Seems a little weird, but that might be, they might have that in there to indicate. If you go to the code book, it might tell you 777 represents somebody that refused to answer or something like that, or gave a possible answer or something. It might mean something. Okay, and how do we know what these things mean, these ones and twos? Well, I'm going to go over to the code book here. I'm going to minimize this. The other thing that we downloaded was the code book, which is, let's see if that's it. See what that is.
This is SAS.
Did I just open it? Oh, no. Yeah, you're right. The wrong kind of file. No. You want to, yes. Oh, we have SAS in here, by the way. That's interesting. Okay. How about that? What's that? Survey? Code book. Let's open that and see what that is. Health survey. It's our code book. Nope, this is our questionnaire, description of our questionnaire. Maybe it's this other file. That's that one. Let's try this. Yep, that's code book. Here's code book. So if we want to know what the values are for ever asthma, right? 1 is yes, 2 is no. If I go back to SPSS, that's question 4.2, okay. If I go back to SPSS, 1 is yes, 2. Let's see, data view. Okay, you go, okay, ever asthma, I'm going to look for ever asthma. I don't think I was that far in. Let me figure out where I am first. Diabetes. So 1, 2, 3, 5, 6, 15. How about diabetes? 1 is yes, 2, so that's about 20 in. Okay, let me go back. Okay. So pretty soon. Oh no. Here we go. I think that's it. Let's hover over that. Ever been told you have diabetes? Okay, we got ones and twos there, right? If I go to my variable view, I can let it know. Okay. Diabetes there, I can let it know that the values, let me bring this together again. The values for diabetes 13, I lost it again. Okay, this row, go across here, that the values that are represented by 1 and 2 is the value 1 is represented by yes. It's hard to type sideways here. And 2 represents no. Oops. And click OK. So now if I go back to my data view, we'll see that it represents this. So when you create your tables and your charts and you do your analysis, your output is going to be labeled with that information rather than with numbers. Okay, ever asthma. Let's do asthma also. I think that was 1 and 2 also. I'm going to say it's 1 and 2. 1 and 2. Ever asthma. 1 is yes. 2 is no. Okay. So let's say I'm not saying that this is something you in a real world you might want to do. Let's say you wanted to see if there's an association between a diagnosis of diabetes and a diagnosis of asthma. Okay. So let's say I wanted to set up crosstabs. So let's say I'm going to call my exposure diabetes. If you're diabetic, are you more likely to have asthma? So one of the problems I have here is there's so much stuff here, it's hard to work, right? So what I might do is I might just highlight all these columns before that. And I might go up here to edit and say clear. They're gone. And I might do that for all this other data too. Right? If you're not using it, right, why not get rid of it? Whoops. Kind of hard to work sideways here. Whoops. What the hell did I do now? Oh, good, it's still highlight. Here it is. Edit. Clear. What am I missing? What did I do? Okay, we still got more. Oh, then Shift key, click that, edit, and clear. Okay, so now I'm left with only 2 variables. Oops. I hope I didn't eliminate them all. Did I? Oh, wait a second. Too many windows open. Edit, undo. And try this again. No, it's not letting me scroll across because I'm not all the way down. Let's see if this will work. Okay, I got it. I know what'll make it work.
Minimize
I know.
it.
Or I should maximize this, one or the other, right? That way I don't keep clicking the wrong window. Okay, make a long story short, now we've eliminated all the other variables that we don't need. So I have a data set, just has to be the data that I really want to work with. Okay, so let's see what we can do with this stuff. Well, we've coded it because we had to recover the coding because we converted it from SAS. Let's analyze this data, right? It's numerical data, excuse me, it's categorical data. Each one of them has two values, 1 and 2. Okay, I'm going to go up to analyze. I'm going to go up to, let's see, not comparing means now, am I? Right? How about descriptive statistics? Well, in descriptive statistics, there's a listing here called crosstabs. Another word for a contingency table, like we have rows and columns. So I'm going to click on that. And in that, I can identify which variable I want to be in the rows and which variable I want to be in the columns. Now, it happens to show you the long version of the label. If you hover over it, you get the whole thing and you'll get the name. Okay, so I'm going to put that into my rows. I'm going to call diabetes for our purpose of exposure. And I'm going to put in the columns whether or not you've been told that you have asthma. Okay, so the first thing I'm going to do over here is I'm going to go up to statistics and I'm going to say, oh, well, look, there's chi-square, that's familiar. And I see risk, there's a few things here that look pretty familiar. But before they do that, I want to get a closer look at this data. Let's go into cells. And one of the things I can do is, right off the bat, out of all this stuff, it has the value observed checked off. So I'm going to just say continue. I'm going to say OK and see what my output's going to look like. And let's see what my output looks like. Here's my output. And my output, let me do it again. Where is it? Upstairs. I'll do it again so I can get this to pop up a little bit. See what my output looks like. Okay, there it is. Okay, have you ever been told that you have diabetes? Yes. Is that exposure? No. Okay, and let's take a look at what the columns are. Have you been told that you have asthma? You have the columns are people that were told yes, people that were told no. Okay, so how many people were in this survey total? Yeah, 8,000, right? 8,800 people were in the survey. How many of those people, how many of those 8,800 people have been told they have diabetes? I'll just say they have diabetes. That's about 1,000. How many people don't have diabetes? About 7,500. How many people out of those 8,000 have been told that they have been told by a doctor they have asthma? 1,100. How many people have not been told? 7,500. Interesting, pretty close, same ratio, right? Okay, so now the real thing we're interested in here is what are the do people that have diabetes are they more likely than people that don't in this population to have asthma as well? So really, I would love to know what the rate of or risk of asthma is for diabetics versus non-diabetics. Let's go back to our analysis. Analyze descriptive statistics. I'm just going through this in piecemeal so I can show you some different functions. You could obviously, when you do this, you're just going to do them all at once. I'm going to go into cells here. One of the selections that I can make here is give me percentages by rows. Percentages by rows is going to be the number of people in that box over the total number of people in that row. Okay, so let's say, and that's what our risk or our rate is going to be. Let's click it in. Okay, so let's see what that looks like. And again, I got to do it twice so you can actually see it. Okay, so let's see what it looks like here. Let's see what this looks like. Okay, so among diabetics, the risk of having, or the rate at which you have asthma is 23%. For non-diabetics, it's 11%. So does it look like there's an association between diabetes and asthma? Kind of looks like it, right? Okay, so 22% is my rate for diabetics. 11% is my rate for non-diabetics. What will my relative rate or relative risk be? Remember what that was? It was the risk for the exposed over the risk for the unexposed. So 22 over 11, what does that look like to you? What number? 2. Looks like you're twice as likely to be diagnosed with asthma if you're diabetic versus if you're not diabetic. Do we know yet whether or not that's statistically significant and not due to chance? We don't know yet, right? Because we haven't done any statistical tests. We haven't done, like a confidence interval. We haven't, and so on and so forth. So that's a risk, but sure, but with 8,000 people, it's sure looking pretty, like some pretty strong evidence. But let's take a look at it again. So now, in addition to that, if we wanted to do odds ratio, we'd have to calculate that another way, wouldn't we? Right? That would be 241 over whatever that is, 825 divided by whatever that is over 6729, right? So that would be our odds ratio. Our risk ratio is this number divided by the total, this number divided by the total for the row, and our odds ratio would be that percentage over the other percentage, right? Okay, our risk is a little bit easier, a little more intuitive, but it's just another measure of this. Okay, so now let's go ahead and I'm going to go back here, analyze descriptive statistics. I'm going to look at this from a different perspective. Okay, I'm going to go into the cells. I'm going to turn off percentages by rows for now. And I'm going to say, look at this. I can ask it to show me the expected values. So I can ask it to give it to me as 2 tables, my observed values and my expected values. So when we used Excel, we calculated the expected values. In this case, we're going to use SPSS to calculate the expected values. Analyze descriptive statistics. Cross tabs. Okay. So let's take a look at what our table looks like now. Well, look, we have a label. We have in each one of these boxes, we have 2 values now. We have the count, which is our observed values, which we saw from before. And now with these fractional values are our expected counts. How did it calculate the expected counts? Calculated a prevalence rate for the whole population, applied that to each one of these boxes, and it did it just the same way that we did. So now you have our observed values, we have our expected values. If you have the observed values and your expected values, what can you calculate now? You can calculate what statistic? Chi-square. Okay, so you can calculate chi-square. Using Excel, we would actually do the calculation. This minus that squared over the expected values. With SPSS, we can actually have it do it for us. Compare means, descriptive statistics, cross tabs. Where is it? Cross tabs. Okay, and let's see, where am I here? Okay, so I'm going to go into cells. I can leave the cells the way it is. I'm going to go into statistics. I'm going to check off chi-square. And I'm going to click continue. I'm going to say OK. Okay, and I'm going to do it a second time so we can read these tables. Okay. Okay, so here's our table. Where is it? Okay, here we go. All right, so here's our table. Remember these other tests we were talking about? Fisher's exact test, the continuity correction, so on and so forth. For right now, I'm just going to look at Pearson's chi-square. What's the value of Pearson's chi-square? 105. That's the same number we would get if we did this in Excel. And it's a big number. Is there any surprise that it's a big number? When you have a large sample, you got big numbers in those boxes. The differences are going to be big. So the number's going to be big, right? So it's one of the advantages of having a large sample, right? 106. Remember roughly what the critical value was? Yeah, 3.8 something, right? Was a critical value for 1 degree of freedom. So it looks awfully likely we can reject our null hypothesis. SPSS actually gives us a p-value. So one advantage here is we know what our probability of being wrong is if we reject the null hypothesis. Not only do we know because of the size of the chi-square, not only that it's bigger than the critical value, but we also know that the probability, the p-value, is really very, very small, less than 0.001. Right? It shows it as 0, but it really just means less than 0.001. Okay, and that's our chi-square value. Okay, so you can use this to demonstrate that there is an association between a diagnosis of diabetes and and having asthma. So, what did we miss here? What other statistic did we just learning about? Odds ratio, relative risk. Let's do those as well. I don't know if you noticed, if I go back to descriptive statistics and crosstabs, right? There's another selection in statistics I could use, and that is risk. I'm going to click that, and I'm going to hit continue and say, okay, I'm going to do that again. Okay. All right, so now we get the box that we have gotten all along. That's the same. Here's our expected our observed and expected values. Here's our calculation for chi-square. Now we got a new box down here called risk estimate. Did I do it twice? Maybe I only did it once. Where'd it go? I see one of them. Thought I did it a second time. Let's do it again.
It's in it.
Yep. So okay. Was it there?
Yeah.
Yeah. It's jumping around so much. This mouse is really jumpy. It's hard for me to get it to stand still. There it is. Now we get a new box in addition to those other two that says risk estimate. What did we say our relative risk was? It was roughly 2, right? Round 2. Well, if you look over here for, well, I'm going to look up here first. Odds ratio for ever been told you have diabetes, yes or no, for asthma. The odds ratio is 2.277. Pretty easy to identify the odds ratio because they say odds ratio, right? So that's 2.27. Now, it calculates a confidence interval for that odds ratio, right? The confidence in 95% confidence interval is 1.941 to 2. Whatever that is, 2.673, right? That's our range for our 95% confidence interval. For the true 95% confident that the true odds ratio for the population is between those two numbers. What's not between those two numbers? 1. Okay, now in this case, we can use confidence interval because we're not trying to look for overlapping confidence intervals. We've got one confidence interval, we're comparing it to a value. So since 1 is outside of that confidence interval, at the level of 0.05, or at least the level of, or even lower, this is 95%. At alpha is equal to 0.05, we can reject the null hypothesis that the odds ratio is 1, or that, in other words, that there's no association between diabetes diagnosis and asthma, right? So we can reject the null hypothesis because 1 is not there. Now, if that odds ratio had been a number less than 1, what do you think that might have represented? What's that?
Well, maybe say that it's protective against.
Bingo. Exactly. In other words, whatever the exposure was, you had less chance of being diagnosed as being an asthmatic than if you didn't have that exposure. So it's protective. Maybe instead it would have been doing a lot of exercise every day, doing no exercise, right? Would have been the exposure instead of diabetes diagnosis. And we might have gotten a negative odds ratio. Now, remember our relative risk was 2. Well, if you read this, for cohort ever been told by a doctor, this is the only one that's equal to 2. And we know that that's, if you look carefully, you'll see that that's the relative risk is 1.99, right? And the confidence interval for the relative risk, 1.75 to 2.359. What's missing from that range? 1 again, so you can also use that as a reason to reject the null hypothesis. Okay? All right, so how are we doing on time? I hope they could hear me. I should have turned this around a little bit. Okay, good. All right, so let's see. 7:43. Okay, so let me think what else. Okay, so I am going to put the database on Blackboard so you don't have to chase it down. The Community Health Survey database and the code book. So you can import it. You can just, I'll save it as an SPSS file so you don't have to do the conversion. You will have to pick out what variables you want to work with and code them, right? You got to code them to tell it what the 1s and 2s and 3s stand for.
I saw the whole thing on their final project.
Did we? I guess we retrieved it from last semester.
For which?
It's already
Yeah.
it's already available.
Yeah, and there's a link.
Oh no, when you okay. So yeah, I'll make sure that it's whatever. If it's not current, I'll make sure it's current or something like that.
Yeah, they didn't post the 2014 one, so.
No, yeah.
It's still current.
Yeah.
Yeah.
Okay.
A little behind.
Yeah, I'll make sure that the code book is up there too. But you guys can actually go through that, and there's a lot of things you can examine. Like this one just now, we just off the top of our heads, those are the two that happen to be interesting to us at the moment. But there's a lot of data on there. Downside is not a lot of numerical data, but now we have a tool that'll allow us to analyze numerical data. Next week, we're going to talk about a tool that'll allow us to analyze. Remember we talked about in the beginning? When we're comparing two sets of numerical data, see if there's an association between them, or in English, a correlation, right? This is actually one place where, the statistics and the real world kind of overlap in terms of meanings. So that word correlation probably does mean something, like as far as statistic is concerned. But we're also going to talk about regression, which is going to also involve, remember we just talked about correlation doesn't mean necessarily causality. It doesn't mean necessarily one thing causes the other, just that there's an association. We're also going to talk about regression. We're going to try and measure if there is a causal relationship and what that might be, if we can turn that into a formula or numbers or something like that. Okay? All right, so let's call it a night. Stop there. I think we were okay. There's another example that's on Blackboard that's in that same area where you guys can, try an example like this. I'm going to maybe post, now there's a homework. I posted homework number 5. It's got like a couple of analysis of variables, analysis of variance examples. It's got one chi-square and odds ratio and relative risk. I posted those for the homework so you can do them for next Monday. I kept it relatively brief because I want you to give it a try, because then you have the answers there. You don't have like a lot of description of what it actually is, but you should be able to at least put in your values that you get for those problems, see if you're getting the right answer or not. So I made it due for Monday, but I really want you to get a try on analysis of variance. Work on a couple of examples yourself like that, and make sure you know how to use it. So then you can apply it as you start. Know what tools you have to work with as you start to figure out what you want to do for your project. And the last thing is going to be that correlation. And maybe like we'll do a half-hour session sometime during the week, where an online session where I'll do something on a really quick and dirty thing on correlation and analysis of variance. So, correlation and regression. So that if any of you thinking are using numerical variables, that you'll at least have a kind of an introduction of what you might be doing with them, what you might be able to do with them. Okay, questions? Good.
So if we use this for a project, would we think that would be enough for descriptive statistics?
Well, descriptive statistics are going to involve more than that. In other words, let's say you just chose this example that I just did here, right? And you're forbidden to choose this example now that I've done it, right? No, I'm joking. Let's say you chose this example. So that's interesting. Gee, that, there is some association. It looks like there's an association between being diabetic and being diagnosed with asthma, right? Well, now maybe you want to describe what this population is. You want to tell me something about it. What percentage of the population is male and female? What are the age ranges of this population? Maybe you want to take a closer look at this data in terms of stratifying it by age. In other words, filtering out just the people that are over 60 to see whether or not, this relationship holds up for younger people, older people. I would think that it wouldn't hold up for, younger people, because they're less likely to be diabetic, or they're less likely. I don't know. Maybe it would, or maybe it wouldn't. They're more likely. You get someone in the range. I think 18 is the minimum age in this survey, right? So if you take people from 18 to 30, and they're diabetic, they're more likely to be type 1 diabetic than type 2 diabetic, right? I would think. I don't know. You guys know more about this than I do. Like, I'm an EOHS guy, so don't take my word for any of this stuff. Right? So I would think, though, they're more likely to be type 1. Maybe there isn't an association between type 1 and asthma, but there is an association between type 2, which would be the prevalent form in an older population. And it's interesting, I don't know, maybe there's even a variable in here where they ask them if they know whether they have type 1 or type 2. I couldn't tell you, I haven't looked for all of them. You might be able to find that, right? Or you might just be able to say, you might know that by in the range 60 to 80 years old, that if somebody tells you they're diabetic, you're 90% sure it's type 2, just because that's that population, right? So maybe you'll see a difference between in terms of asthma in that group versus a younger group. Now, so there's a lot of ways you could look at this data, but you're going to want to describe to me who these people are, right? Descriptive statistics, you want to describe what this population that you're working with is. What age ranges are they? Are they predominantly older people, younger people? Right, just gave you some important information right there. Nobody in the study is under 18, right? Maybe just by the way they sampled, maybe they're predominantly female. We don't know, but you could find out. Gender is one of the variables. You could certainly do that, and you're going to give us some graphs, show us what the distribution of the population is, especially if it's relevant to what we're talking about. And diabetes diagnosis and asthma diagnosis might be relevant to age and gender and so on and so forth. And you can look at it from more than one perspective. What is gender also impact asthma diagnosis? What else do you think might impact? Smoking status, right? That's in there, I think, right? Okay. So get creative, right? You got enough data there. Plus we have other databases you can play around with too. And if you have data that you're using in other classes or you have projects that you're working on or something like that, maybe there's some stuff you can do there.